Hello students, welcome you to this session. We are studying sets, right? One of the very simple topic. We studied the set operations, right? Union, intersection, difference, then symmetric difference. Then finally we studied Venn diagram, how to shade A union B, A intersection B, A difference B, right? So today I am going to teach some of the properties. There are some very important properties are there, and I'll explain how to verify these properties using Venn diagram and using sets. Okay, let us start with the simple property. The first one is commutative. What is commutative? You know, suppose you take two numbers, 5 and 3. You add it. How can you add it? Either 5 plus 3 or 3 plus 5, right? Both answers are same. So 5 plus 3, your answer is 8. 3 plus 5 is also what? 8 only. So 5 plus 3 is same as 3 plus 5, right? You can reverse the order. So this property, we call it as what? Commutative property. Even if you reverse, there is no change. But if you take subtraction, listen, suppose 5, same two numbers I am taking, 5 and 3. What is 5 minus 3? 2. 3 minus 5? 2 only, but minus 2, right? Minus 5 is there, right? So minus 2. They are not same. So subtraction is not commutative, right? Addition, commutative. So same way in set, we studied some operations, right? Union, intersection, difference. Let us see one by one. So here, union of sets is commutative. Union of sets is commutative. What is the meaning of that? Union of sets is commutative means you take two sets A and B, you find A union B and B union A. You can see both answers are what? Same. Okay, already we saw some examples already. A union B is B union A. So we say union of sets is commutative. Intersection also commutative only. Intersection of sets is commutative. What's the meaning of intersection? You take the common elements. Union means you write everything but without repetition, right? So intersection of sets is commutative. So how can you write using symbols? A intersection B is equal to B intersection A. Okay, so union is commutative, intersection is commutative. And the third operation what we studied is difference, right? So set difference is not commutative. Even this numbers also the difference. Subtraction is not commutative, right? So set difference is not commutative. So what's the meaning of that? A difference B is not equal to B difference A. You know the meaning of A difference B. In A, but not in B. But B difference is in B, but not in A. So, okay, so you won't get any common elements, right? So they are not equal. So these are the three operations we studied: union, intersection, difference. Union and intersection are commutative, but difference is not commutative. Now let us see the next property. You know the next property is called associative property. Please listen here. Suppose I am asking you to add the numbers 2, 7 and 8. So how will you add it? Some students will add like this: 2 plus 7, it is 9, 9 plus 8, right? 17. Some other very intelligent students, what they do, no? They add like this: 8 plus 2, immediately say 10, right? 8 plus 2, 10, 10 plus 7, 17. So even if you change the grouping, can be grouped in any form, your answer remains what? Same. So this we call it as associative property. You can say 2 plus 7 plus 8 or 2 plus 7 plus 8. You can write in different ways. Okay, so grouping can be different form. But your answer is same, so we call it as what? Addition satisfies associative property. Even subtraction won't satisfy here also. Okay, so in set, union and intersection satisfy associative property. Union of sets is associative. What's the meaning of that? So learn all these things. Associative means you must know what it is. Because when you go for the examination, they give 3 sets. They'll ask you to verify associative property of union. Okay, like that they can ask for intersection, anything. So you must know the property. Union of sets is associative. So you have to take three sets. Let A, B, C be three sets. Then A union B union C. Here also you write A union B union C, but grouping only. In the first case, if you group first and second, the second case you group second and third. Both answers will be same. So what's the difference here, When you find the left side, first you find the term inside the bracket. Inside the bracket, what is there? A union B. You have to find A union B first. With that answer, you take the union of what? C. That is for LHS. But for RHS, you find the term inside the bracket. What is inside the bracket? B union C. So you find B union C first. Then with that answer, you take the union of what? A. Hope you understood the difference. Okay. So union of sets is associative. Intersection of sets also associative. Intersection of sets is associative. So you can, you know how to write it symbolically, right? A intersection, even the order can be changed. Suppose I'm writing A intersection B intersection C equal to A intersection B intersection C. Or the right side you write here, left side, and you can say nothing wrong in that, okay? So but throughout it is intersection only, right? Throughout it is intersection. So for the left side, first you find the term inside the bracket, B intersection C, right? Then A intersection. Intersection means common elements you take. Okay, same way right side, first you find A intersection B. Here also, set difference is associative or not? It is not associative, okay? Set difference is not associative. So how can you write this symbolically? So A difference, B difference C is not equal to A difference B difference C. So hope you understood all these things. So the next property we call it as what? Distributive property. Distributive property. So distributive property means, look here, in algebra, suppose A into B plus C. A into B plus C. How can you write this A into B plus C? You can expand it, right? You can write it as A into B plus A into C. This only we call it as distributive property. What is happening here, multiplication is distributive over addition. Multiplication is distributive over addition. So also you can write A into B minus C. A into B minus C. You can write it as, you can expand it. How? A into B. A into B minus A into C. So this we call it as multiplication is distributive over subtraction. The other one is multiplication is distributive over addition, right? Same way, in set also we have distributive property. There are two properties here. The first one is A intersection B union C. A intersection B union C. You can write it as A intersection B union A intersection C. Just see the position. Sometimes letters may change. Instead of A, B, C, they may give M, N, P, something like that. Okay. So A intersection B union C. First A intersection B, then union A intersection C. So A intersection B union A intersection C. This we call it as intersection is distributive over union. Intersection is distributive over union. And one more. That is A union B intersection C. It is not like associative. Associative means union means in both the places union. Intersection means both the places intersection. But here one union, one intersection. Our first one is intersection, second one is union. So A union B intersection C. Can you tell me how to write? A union B intersection A union C. A union B, your answer is A union B intersection A union C. So these two properties we call it as what? Distributive property. So they can ask to prove by giving three sets, or sometimes they'll ask you to prove using Venn diagram. Okay, they can ask us a 5-mark question. So remember the properties. Sometimes they won't give the statement. Question will be verified distributive property. So you must know what is distributive property. Okay, there are two properties. Then the next one, Demorgan's law. Demorgan's law also, we have two Demorgan laws, two types. One is for two sets, or we call it as Demorgan's law for set complementation. Complementation means what? A dash. What is A dash? Elements which are not in A, but it is in universal set. That is A dash, right? So Demorgan's laws for set complementation are similar. I'm writing for two sets. Demorgan's law for two sets. Okay, so here we have two laws. One is A union B, the whole complement, whole dash. A union B, the whole dash, can be written as A dash. The union become, when you take the complement of union is intersection, just opposite, right? So A dash union become intersection B dash. So what is A union B, the whole dash? A dash intersection B dash. Then same way another one, you can say the answer now itself. What is the next one? Instead of union, intersection, right? A intersection B. A intersection B, the whole dash. What's your answer? A dash. That intersection become union, right? A dash union B dash. Okay, so these are the two Demorgan laws for set complementation or for two sets. So question may be sometimes verify Demorgan's law. So read the question fully, not only the Demorgan law for set complementation or set difference. Next I'm going to teach that. There are two types of Demorgan's laws. Okay. So this is for two sets. They give only two sets here. So A union B, the whole dash is A dash intersection B dash. Union become intersection, intersection become union. Okay. So let us go for the next one. Demorgan law for set difference. The first one is set complementation A dash. Set difference minus A minus B, in A not in B, right? So Demorgan law for set difference, or you can say for three sets. Here they give three sets. Here also we have two laws. The first one is A minus B union C. Listen very carefully. A minus B union C. Like distributive property only we are going to start. How you know? A minus B, then A minus C. But here union is there, but outside what you have? Minus. So minus union, it become intersection. Okay, remember like that. Union is there, but outside minus is there, no? So it reverse it. Union become intersection. So what's the answer for this? Tell me. A minus B union C is A minus B. The union become intersection. Remember, outside there is a minus. So that makes the union as what? Intersection. Like that, this is for you to remember only. Okay. A minus B intersection A minus C. And another one is A minus B intersection C. A minus B intersection C. What's your answer? A minus B. The intersection become union, right? Union A minus C. So hope you understood all these things. First learn all these results, okay? Then easily you can do the sums, okay? Just Demorgan laws, there are two types. One is for set difference, another one is for set complementation, okay? So hope you understood all these things. So just I want to give some more results. Some in your books they give some corner, some boxes, they give some important steps, okay? So don't think this is, we don't want that. So learn that also, okay? So that the exercise, some examples, everyone will study, right? If you learn that extra thing, some remarks, some results, do you know? If you learn, go through all these things. They may not ask for the examination, but still, if you know all these things, you will be in the better position, right? So you can answer any question. You will be in the top layer, okay? So prepare all those things also. Some of the things you will study in the higher classes in detail. This is one thing, idempotent law. In 11th standard, it is there. Okay, what is idempotent? So in 9th standard book also it is there. So just to go through all these things, idempotent, A union A. You know what is A union A? Suppose A is a set, A is 1, 2, 3. Another A, same set only, 1, 2, 3. What's the union of A and A? What is A union A? Write everything, right? Without repetition. So 1, 2, 3. So your answer is A only, right? A union A is A. What is A intersection A? You take the common elements. What is common for A and A? All the 1, 2, 3. That is same as what? A only. So if there is no change, A union A, your answer is A. A intersection A, it is A. So this law, we call it as what? Idempotent. Okay, try to remember this. Next one is identity law. what is identity? In addition, 0 is the identity element. In addition, 0 is the identity element. Why? A number plus 0, your answer is that number itself. Any number you take. Any number plus 0, you will get that number only. So 0 won't make any difference, right? So 5 plus 0, it is 5. So 0 is called identity element for addition. Same way for multiplication, can you guess 7 into something, you have to get 7 itself. 5 into something, you have to get 5 itself. Which number? 1, right? So 7 into 1 is 7, 5 into 1 is 5. So such a number we call it as identity element. So remember, for addition, what is the identity element? 0. For multiplication, what is the identity element? 1. What is the role of identity element? When you operate, there won't be any change. Okay, in the higher classes, all these things you need. The basics you learn right from 9th standard. Okay. Same way here, identity law. For union, what is identity law? What is identity element? What is identity element? A set, union something, you have to get A itself. It can be any subset of A, but normally we take it as empty set. A union empty set. A union empty set is what? A only. So with A, if you attach empty set, there won't be any change because in empty set nothing is there, right? So A union empty set is A. Same way for intersection. A is there, A intersection, universal set. Universal set means it contains everything. So A is a small set. Okay, A intersection universal set. What is common in both? A only, right? So this union is the identity for intersection and empty set is the identity for union. Okay, so just remember all this. These are something extra for you. Now let's go for few sums. Okay, see the first one. Sum number, first one is a very simple sum. P, Q, R, S. 4 sets given. But everything is given in which form? Roster form. So it's very simple, right? So if it is in set builder form, you have to convert it into roster form and do that part. You have to be very careful, that's all. Okay. So few sums I will teach you fully. Then later I just will give you some idea so that you can complete it. Okay. P, Q, R, S, 3 sets. So first they asked find P union Q union R. So first you find the term inside the bracket, right? So first you find P union Q. So P union Q means P, Q, everything you write but without repetitions. Okay, try to write in order 1, 2, 3, 5, 1, 2, 3, 5, then 7, 9, 11. 7, 9, 11. This is P union Q. Now P union Q union R. So with this you attach R also. So already you have this many elements, the right P union Q. With that you attach this R also. If anything left out here, if it is in R, you write that also, right? So 1, 2, 3, 1, 2, 3. 4 is here, no? That 4 also can be included. 4, 5, then 7, 9, 7, 9, then 11. 7, 9, 11. That's all. This is the answer for the first part. See the second part. P intersection Q, right? For the second part, first you find the term inside the bracket. What it is? P intersection Q. P intersection Q means the common element, right? Common for P and Q. For P and Q, see what is common? 2 is common. 5 is common. 9 is common, right? Say what are the common elements? 2, 5 and 9, right? So these are the common elements for P and Q. Now we have to find P intersection Q intersection S. P intersection Q, you got it. Now we take this S also, the common for these two. 2 is here, 2 is here, right? 2 is common in both. So in the answer you can write 2. Then 5 is common in both. So 5 you can write. 9 is not common. So that's all, right? 2 and 5. So very simple question. Now let us see the second question. Test for commutative property. So you know what is commutative property? For of union and intersection, both they asked. So A union B equal to B union A intersection B equal to B intersection A, right? Instead of A and B, here they given P and Q. But this sum, you have to be very careful in doing this. Okay, so listen very carefully. Looks like very simple, but you have to be very careful in this one. So P equal to set of all x such that x is a real number between 2 and 7. And Q is set of all x such that x is a rational number between 2 and 7. Both between 2 and 7 only, but you must know thoroughly what are real numbers, what are rational, what are irrational. Then you can do the sum very easily. Listen, there are two types of numbers. One is rational number. Rational numbers. Rational numbers means numbers of the form p by q. All the fractions 2 by 3, 1 by 7, even 5. 5 means 5 by 1, right? But one thing, both p and q must be integers. It cannot be some root 7 and all, right? P and q are integers. And the denominator not equal 0. Such numbers we call it as what? Rational numbers. All the numbers, suppose root 2, root 3, root 7, root 5, all these are called what? Irrational number. So rational number, irrational number. Then what is a real number? Real number is the union of both. Rational number, set of rational number, set of irrational number. Together we call it as what? Real number. So the larger one is real number, like our universal set, right? Universal set, like that only the real number. It contains rational, irrational. Rational number cannot be irrational number. Irrational number cannot be rational. Like odd number, even number, right? Odd numbers, even numbers. Nothing is common. You cannot take some number, you say it is odd number, it is even number. No, right? It is either odd or even. Same thing only. It is rational or irrational. But everything together we call it as what? Real number. Okay, now please listen here. I take a small diagram so that you can understand better. So just I'm taking a Venn diagram like this. Okay, so this is, I'm taking this as set of real number. This is set of real number. Real numbers and real number. Okay. Now I'm taking this real number, I'm dividing into two. What are the two things? One is rational and irrational. Rational number, irrational number, together it is what? Real number. Nothing is common for them, right? Okay, now listen here. Here we want two sets. One is P. P is set of all x. I said x is a real number. So this is our P. P is set of real numbers between. So in this case they said between 2 and 7. Okay, both are between 2 and 7 only, so don't worry about that. P is set of real number between 2 and 7. Q is set of all x. I said x is a rational number between 2 and 7. So this is our Q. So in the question, if they say irrational number, you take that as Q. That's all. So now it is very simple, no? Listen here. P is the full set. Q is only that part, right? Can you say what is P union Q? P and Q. P is the full portion. Q is that portion separately. What is the union? You take the union means the whole thing you should take, right? So your answer is P. P union Q is P. Q union P. Q union P. What is that? That is also P only, right? So it is shade both. So from 1 and 2, I'm taking this as 1 and 2. So from 1 and 2, P union Q equal to Q union P. Therefore, union is commutative. Okay, now intersection they asked. Listen carefully. Now let us find the intersection P intersection Q. See the diagram? P means the full portion. Q is only that rational number, only that portion. What is intersection? What is common in both? This portion is common in both, right? Because this is in P, also it is in what? Q. So P intersection Q is what? Q. Q intersection P, that is also what? Q only. So we name them as, say 1 and 2 already we used. I'm taking 3 and 4. So from 3 and 4, the right sides are equal, so the left sides are equal, right? So P intersection Q equal to Q intersection P. Therefore, intersection is commutative. Okay, this is how we have to do this sum. You cannot take numbers and all. Sometimes you may think between 2 and 7. So between means so you cannot take 2 and 7. You may think the numbers are 3, 4, 5, 6. No, it is wrong. Because real number means everything. Even the decimals. 2 you cannot take. After 2 which number? Don't think 3. Natural number means after 2 it is 3. In real number, after 2, what's the number? 2.5? No, some more before that. 2.1. Still some more. 2.0001. It starts like that. Then 7 you don't take. Before 7, which number? It is not, they didn't say about it's a whole number or integer, nothing. So before 7 means 6.9999, right? So you cannot write everything like that. So you cannot write it in roster form here. So you can do like this. So hope you understood this. Now let's go for the next question. Listen. A, B, C, 3 sets. Verify associative property of union of sets. Simplest question, right? Everything is given in roster form. So, but you must know what is this property, right? That's the reason I said. So learn the properties. Associative property of union. So to prove, so to verify. So first you must know what you are supposed to verify, right? So associative union is associative, we have to prove. So A union B union C equal to A union B union C. Okay, this is what we have to verify. We find LHS, RHS separately. For LHS, first you find the term inside the bracket. What is that? B union C you find. So B, C, everything you write. M, N, P is there, right? P, Q. Then ST. This is B union C. Now A union B union C. A union B union C. So with this you attach that A also. So in A we have PQRS. PQS is R also you have to include, right? So M, N, P, Q, R, S, T. So B, A union B union C. Take it as equation number 1. Now for the right side, first you find the term inside the bracket. What is that? A union B. So first you find A union B. So A and B. So see the set, take the set very carefully. So now A and B you take A union B. So M, N, P, Q, R, S. M, N, P, Q, R, S. Then T is also there, right? This is A union B. Now we have to find A union B union C, right? So with this answer, you attach C also. In C, what do you have? M, N already here, P, Q already here, S already there. So nothing else to write, you write, just copy the same thing. M, N, P, Q, R, S, T. Take it as equation number 2. Check 1 and 2. Are they same? If they are not same, you have to check again because they should be same. So union is associative. It will be true. Don't say it is false. Okay, it is not satisfied. No, you would have made some mistake. You have to check it. Okay. So union of sets is associative. So both answers should be same. If not, you have to check it. So from 1 and 2, you can say A union B union C equal to A union B union C. Write the conclusion. Therefore, associative property of union of sets is verified. Therefore, union of sets is associative. Okay. See the next question. Verify the associative property of intersection. Verify the associative property of intersection. Here also they given everything in roster form. Very simple. So to verify. So what did verify here? Here the sets are A, B, C only. Intersection is associative. So A intersection B intersection C equal to A intersection B intersection C, right? We have to verify this. So we find LHS. For that you find B intersection C. Intersection means common, right? So what are common for B and C? For B and C, what is common? Root 3 is common. Root 5 is common. Anything else? 6 and 13 is not there. Okay. So now A intersection B intersection C. So common to B intersection C and A. See what is common in these two. Root 3 is not common. Root 5 is common. So only root 5. So this is the answer for LHS. Now we find RHS. To find RHS, first you need the term inside the bracket. What is that? A intersection B. See what is common for A and B. For A and B. Minus 11 is not common. Root 2 is not common. Root 5 is common. 7 is not there, only root 5, right? So this is A intersection B. Now we find A intersection B intersection C. Common for this A intersection B and C. What is common in both? Only root 5. So take it as number 2. So both answers are same. So from 1 and 2, A intersection B intersection C equal to A intersection B intersection C. Therefore, the conclusion you write, intersection of sets is associative. So they'll ask you to verify in 2 ways. One method, they give some set, they'll ask you to verify. Sometimes they'll ask you to verify using Venn diagram. Okay. Now let's go for the next question. Very important question. Listen very carefully. It is given in set builder form. So writing in roster form, you have to be very, very careful. See, what is A given here? A equal to set of all x. A equal to set of all x such that x equal to 2 raised to n. X equal to 2 raised to n, where n belongs to w. W means whole number starting with 0, 0, 1, 2, 3, 4, etc. And n is less than 4. For n, there are 2 conditions. For n, there are 2 conditions. N must be a whole number and n must be less than 4. So can you say what is n for this question? It is a whole number less than 4. Can you say all the whole numbers less than 4? 0, 1, 2, 3. These are the whole numbers less than 4. N belongs to W. N is a whole number and n less than 4. Less than or equal to means you take 4 also. Here don't take 4. Before 4, don't think it is 3.99 like previous question. That is for real number. Okay. So here it is a whole number. So before 4, what's the whole number? 3 only. So 0, 1, 2, 3. But don't write this as your answer. Our answer is set of x. So this is n. We have to find x value. Okay. So listen, how to find x value, you know? X is equal to 2 raised to n. X is equal to what? 2 raised to n. So take the first n value. What is the first n value? 0. So the first value you write 2 raised to n means it is 2 raised to 0. Then n value 1. So 2 raised to 1. Then x is equal to 2 raised to n. N value. So here since n is 2, it is 2 raised to 2. Then 2 raised to 3. So can you say the answers? Any number raised to 0, it is 1. Any number raised to 0, 2 raised to 0 or 7 raised to 0, the answer is 1. 2 raised to 1, 2. 2 raised to 2, 2 into 2, 4. 2 cube. Some of you may think it is 6, right? So be very careful. Even the bright students, sometimes careless mistake they make. 2 raised to 3. Think 2 into 2 into 2, right? 2 2s are 4, 4 2s are 8. So okay, this is our A. So A equal to 1, 2, 4, 8. Hope you are clear in this one. Okay, so that's very important. Now let us see B. I am going to explain that also. Then C is already given in roster form. Then whatever they ask, you can do that, right? Now let us see how to write B. B equal to set of all x such that x is equal to 2n. And what is n here? N belongs to n and n is less than or equal to 4. Here also one n is there, right? But we won't write x. But x is given in terms of what? N. X is equal to 2n. If you know n, then only you can find x because x is equal to 2 into n. If n is 3, x is 2 into 3. Okay, so first you have to find the values of n. Using that n, you have to find the values of what? X. Okay, so now let us see here. N, this is what you have to see. N belongs to n. Capital N is a natural number. Previous one, it is whole number starting with 0. Natural number starting with 1. So n is a natural number starting with 1. And one more condition, less than or equal to 4. So up to 4 you take. Can you say the natural numbers less than or equal to 4? So the natural numbers less than or equal to 4 are 1, 2, 3, 4. Hope you understood. Less than or equal to 4. Okay, this is n value. Don't take it as B. B is set of x. So now you have to find the x value. X is equal to 2 times n. So the x values are 2 into 1. The first value is 2 into 1. Second value 2 into 2. 2 into 3. 2 into 4. What is 2 into 1? 2. 2 into 2? 4. 2 into 3? 6. 2 into 4? 8. So these are the values of B. So B equal to what you are getting 2, 4, 6, 8. So, okay, hope you understood this. Now I'm going to write them together and let us see what they asked to find. So A equal to 1, 2, 4, 8. B equal to 2, 4, 6, 8. And C, it is given in roster form itself, right? 0, 1, 2, 5, 6, 0, 0, 1, 2, 5, 6. Okay, all the three sets you know. Now you see what they asked to find. Verify. What do you have to verify? Associative property of intersection. That you know how to do that, just to help you a little bit. Associative property of intersection. So to verify associative property of intersection. So A intersection B intersection C equal to A intersection B intersection C. This is a very important question they can ask in 5 marks. So to find left side, first you find the term inside the bracket. What is that? B intersection C. So find B intersection C. What is common for B and C? B and C. Don't look for A and B. Okay, you should not make any careless mistake. Very careful. B and C. What is common in B and C? 2 is common. Then 4 is not there. 6 is there, right? Yes. 4, 2 and 6. 2, 6. B intersection C. Now you find A intersection B intersection C. Common for B intersection C and A. B intersection C and A. See what is common in both. 2 is common, 6 is not there, only 2. So this is the answer for LHS. Now we have to find RHS. RHS first you find what? A intersection B, right? So find A intersection B. Common for A and B. A and B. See what is common? 2, 4, 8. 2, 4, 8. Now we find A intersection B intersection C, right? A intersection B intersection C. Common to this A intersection B and for C. See what is common in these two sets? 2 is common, 4 and 8 are not there, only 2 is there, right? Take it as 2. See 1 and 2, they must be same, right? So both are same only 2, a singleton set. So from 1 and 2, you can say A intersection B intersection C equal to A intersection B intersection C, right? So therefore, intersection of sets is associative. So today I explained only all the properties we studied, but verification we did only associative property and commutative property. Then some more we studied, right? Distributive property, then Demorgan law, go through everything. Then how to verify those properties, also how to verify using Venn diagram, I will teach in the next video.